Welcome back, Mindsetters. Wow, the interaction on the page is absolutely fantastic. I knew you guys would really enjoy the show, and you really are. Thank you for your participation because you guys make this show possible. If you have just joined us, please jump onto the page to see what's going on because it's really, really great, guys. And come up with more questions. Your questions are already on the board. We can tell that you guys are interested and that you're understanding. So thank you for that as well. Over to you, Bruce.
Great, thanks, Kat. Yeah, during the break, I went and had a look at some of the questions on the Facebook page, and they really are good ones. And I'm going to take a couple of questions just now off that Facebook page, and hopefully be able to answer a few of you live, and just sort of get to know it. Because the important thing is you guys are inquiring about it, and what's nice and what I've enjoyed seeing your questions is that you guys are interested and you're asking nice probing questions, and I'll certainly attempt to answer them as best I can. Let me just finish what I was doing just before we had to take the break, and we were talking about how coal is how we form coal through the heat and pressure of these organic remains in the Earth's crust that forms a solid black mass, which now is our coal. Okay, now just to conclude that, what we've got to talk about is energy. And where does the energy come from? Well, the energy that we use is that the energy is stored in coal. Coal has got the ability to have a large amount of stored energy there. That is why when you ignite coal, you will get a very, very large amount of heat being given off. Okay, so coal itself, all the energy from those millions and millions of years ago when those animals died and the trees died and the vegetation, the plants died and were compacted, all that energy from those organisms are now trapped and held in the substance. And when we now ignite coal or light coal, then that energy escapes. And that is why coal burns with such a great amount of heat. And that really gives us a lot of uses for coal. Okay, a lot of people jump up and say, oh, but we have a great braai and all that. Absolutely, we do use coal or a form of it called charcoal. But where we can use lots of heat energy is obviously more for these practical purposes. Right, we can use them in stoves. Some people may still have the good old coal burning stoves at home. And we can use that then to prepare our food. Because we have lots of heat, we can then boil water, we can cook, we can do all sorts of things because of the energy that is distributed by burning coal. In the cold, coal is used to provide heat. Okay, so during those bitter, high-felt winters that we have, and even down in the Cape when it really gets cold and miserable, guys, what we can do, we can burn coal. Okay, and we get a form of coal called anthracite, and anthracite is then used to release energy, and that heat energy will keep us warm. And then obviously the third one is the very obvious one that we can use to produce electricity in our coal burning power stations. So there, guys, is basically how we form coal, some quick uses for coal. And as I said, I'm going to take a couple of questions quickly, and then I'll get back to our lesson. Kat, some questions there.
Okay, so there's a question by Zwibuya. He asks, or she asks, sorry, I'm not sure. Does CO2 come from cutting down trees?
Okay, no, you cannot produce CO2 by cutting down trees. But we've got to be very aware of a big environmental problem if we start cutting down too many trees. Okay, sure, we have to cut down certain trees because we have to use it to make pulp and paper. Okay, there is an industry that is a multi-billion dollar industry associated with that. However, carbon dioxide, okay, is actually used by the trees to create oxygen through the process called photosynthesis. Those guys who do life science will probably be very aware of that term, photosynthesis. So therefore, during the day, green plants, green trees, the leaves on the trees, they've got a substance called chlorophyll that makes them green. But it's that chlorophyll that is essential in the process called photosynthesis. And what that does is that it actually takes carbon dioxide, okay, and produces oxygen. Okay, now I'm not going to go into the very heavy chemistry of it, but just be aware of it. So it's important that we are not cutting down too many trees because we call these things carbon sinks. I'll actually just write that word down here because I actually really like that question that's come in. A carbon sink. Okay, and what it means, and if you think about it, we talk about a sink. A sink is where stuff goes down. So it basically what it's doing is pulling, it's taking the carbon dioxide, taking it out the atmosphere and producing oxygen. Okay, that is why the deforestation of our natural forests and jungles is a huge problem. If you think about the Amazon rainforest, okay, as one of our prime examples, the Amazon rainforest has been decimated over the years, okay, and only now in recent times, the last 20 years, has there been enough legislation in those countries to prevent the decimation of the Amazon rainforest. People saw it as an easy source of wood. They were just going in there, cutting down the trees all over the place, and what was happening is that deforestation was removing our carbon sinks. So in other words, we were limiting the amount of vegetation, or should I say reducing the amount of vegetation that was now taking in carbon dioxide and releasing oxygen. So therefore, that created a buildup of carbon dioxide as well, and that contributed directly to the increase of greenhouse gases and global warming. So yeah, big problem was that.
Okay. And then there was a few asking about the chemical formula of coal. Please let them know.
Okay, there's no specific chemical formula for coal. Coal consists of a number of chemicals. The main chemical in coal is carbon. Okay, so carbon is the main element. Let's use the word element in the actual structure of coal, because remember, it comes from organic matter. Now, I'm not too sure whether you guys have spoken a bit about organic chemistry and things like that, but all living organisms are comprised of organic molecules, and organic molecules are all carbon-based. Okay, if we take ourselves as a living being, we are comprised of a lot of organic molecules, and therefore we've got a lot of carbon in our structure. It doesn't mean now that we look like coal, absolutely far from it, not at all. But all our proteins, our fats, our carbohydrates that we have are all carbon-based. Our DNA, the structure of our cells, yes, is all carbon-based. So therefore, when these animals and plants, the living organisms died, and they were subjected to the pressure and the heat under the Earth's crust, okay, your carbon then was actually put together to form your coal. So it's mainly based on carbon. However, there are other elements in there. Other elements, very specifically, will be sulfur, okay? And we do have some nitrogen-based elements as well. So what we've got is basically carbon, we're going to have sulfur, and a number of nitrogen-based elements. So therefore, when we burn the coal, we are going to react it with oxygen, the burning combustion process, and therefore we are going to start releasing now carbon dioxide, sulfur dioxide from the sulfur, and these nitrogen oxides as well, which are the problems with our greenhouse gases. Okay, and the sulfur dioxide, that brings in another problem. I am going to chat to you guys about it a bit later. It brings in the formation of what we call acid rain, and I think we all know that is also a very, very serious environmental problem as well. So the burning of coal has got a lot of nasty things associated with it. Okay.
So there's one more that I just want to read out to the mindsetters that you will go throughout the show. So you don't have to answer it right now. Okay, it's by Chifiwa. She says, "Hi, I have noticed that coal is used in various processes, i.e. electricity, production of iron. Why can't we attempt to use alternative ways to provide energy? For example, solar, wind, or nuclear, etc. Is it possible to change our energy source, like how they changed the old classic light bulbs to CFLs?"
Can I answer that, if you don't mind? And I'll just be very brief. Guys, we are always looking for alternative energy sources. Okay, we are very aware that burning of coal is very dangerous to the environment. We're also very aware that it's a non-renewable resource. So therefore, we are looking for alternative energies. But obviously, it costs money. Okay, it can be very expensive. But we are slowly getting the resources together. So yes, we do have nuclear power. Okay, nuclear power is massively clean. It doesn't give any emissions. Okay, in terms of carbon dioxide or nitrogen oxide or anything like that. So therefore, it's called a clean process. So yes, nuclear power is something we're looking at. However, there are its own associated dangers with nuclear power in terms of accidents. And we have had a couple of quite serious accidents. 1979, we had an accident in America, 3 Mile Island. 1985, we had Chernobyl, and I'm sure you guys have all heard about Chernobyl. That was really, really serious. And not so long ago with that devastating earthquake and tsunami in Japan, the nuclear power station in Japan was very, very badly damaged, and they were very lucky that they did not have a bigger disaster than they had. So nuclear energy is a problem, but we are looking at wind farms to provide wind power. We are looking at wave power, tidal power. And then a big one, and we have in this country, is hydroelectric, use of water, okay, to turn the turbines. Also a very clean process. So yes, we are on the ball, we are on the map in terms of getting alternative energy sources.
Okay, sure.
Okay, cool. Right, guys, so let's go and get back. And as I said, guys, where do we get this coal from? Well, we have to mine it, okay? It doesn't just fall out of the sky. It doesn't just grow on trees. We have to get it out the ground. So how do we do it? Well, there are 3 ways of being able to remove coal from the ground. And these are 3 mining techniques, and I'm going to briefly go through them with you. The first one's called strip mining. Okay, the second one's called open cast mining, and the third one is called underground or deep shaft mining. Now, those 3 techniques that we use now for our for mining is going to be very dependent on where the coal is in the Earth's crust. So let's have a look now at the first one, which is strip mining, and I've actually put a little managed to attach a little diagram there where we can see an example, and this is actually a mine that is quite near Witbank. Okay, and which has got a large amount of coal deposits, and this photograph was taken from there. And we use strip mining, this is a form of very shallow mining, okay, when the coal reserves are quite close to the surface of the earth. Okay, in other words, when they are very, very shallow. So we don't have to dig down to go and get it, okay? We can basically take the land, we find the coal underneath, okay, and we basically extract the coal. There is a positive side to strip mining that although it doesn't look very pretty, and if you look at the diagram, it doesn't look very pretty at all. However, what they're able to do, because it's so shallow and they haven't taken a huge amounts of earth away, they're able to actually patch that up. So they can actually almost repair the environment a little bit and sort of try and get the ecology back once they finish getting the coal out. Okay. A little bit of detail on that. They call the top sediment so that they remove to get the coal underneath. They call it the overburden. And they remove that overburden so that the coal reserves are exposed underneath. And then this sediment, this overburden, is replaced once mining is finished in an attempt to rehabilitate the area. Okay. So strip mining, at the end of the day, is probably has the least impact on the environment itself. Okay, now, open cast mining is a lot more damaging. The reason being is that open cast mining is used when the coal deposits are just a little bit too deep. Okay, they cannot get to them simply by removing that overburden. So they have to go down now, and they've got to start digging down. Okay, but they don't dig down with long shafts. They dig down, and basically, if you have a look at the diagram, you will see now these little tiers. I'm going to, whoopsie, let's get my pen here. You can see like it's almost like a layered effect, okay? And it goes down deep into the ground. So what they do is they sort of work on sort of almost a circular type of format, and that circular little format goes down layer by layer by layer by layer, and then they take the coal out. So they go deeper and deeper and deeper. The problem is now that they're taking huge amounts of earth out of the crust, and they don't put that earth back. They actually move that earth away, and they create dumps, mine dumps, from the earth that they don't use, and therefore they don't now rehabilitate the area. So the problem with open cast mining is that you are not going to be able to rehabilitate the area. So it does leave a rather unsightly scar on the environment itself. Okay, and as I said there, the mine is a deep terrace structure where the overburden is taken away and dumped away from the mine, so we don't refill it. And these mines are too deep to try and rehabilitate, and thus leaves a huge pit in the ground. Okay, one of the unfortunate things of pit mining. Right, and the third one, okay, is our underground or deep shaft mining. So now they're going to actually sink shafts down into the ground. That's when the coal reserves are too deep, okay? They're far too deep to actually go through and do open pit mining, okay? They're going to have to drill down and go and extract it from there. And we talk about usually deeper than 40 meters. So if the coal reserves are deeper than 40 meters under the ground, then they're probably going to start looking at shaft mining. Okay, and there I've just got a picture of a coal mine. You can see a typical shaft where they will then drop the miners down, and then what will happen is that they will basically tunnel out of the shaft. So if let me just quickly do a little diagram for you. So if you've got a shaft like, whoops, let's get the pen working. There's the shaft like that. Okay, it goes down. What they will have, they will tunnel out in both directions, okay, and they will basically be mining the coal, okay, at these various spots in the tunnel, and then that coal comes back, and then they basically take it back up to the surface, and then that coal is then extracted. So guys, that's basically underground or deep shaft mining. Okay. Let's take a little break.
Let's take a
break. And
break.
we'll come back and we'll basically conclude the section.
Okay, awesome.
Okay.
So you guys heard that. I know there are some other questions, and that we've answered some of them, as you already know, and you're happy about. So send through some more if you may have on what Bruce has just done. See you right after this short break.